Hello everyone, Assalamu alaikum warahmatullah, and welcome to the last video in the seismic survey training course. In this video we will cover the design on map mini application inside the SQL query application. So to go to design on map, you will go to the map, design, open the design on map. As we said before, it's very similar to the offset on map application. So it has similar interface but different tools. Also same import, same export tools. So we will not repeat the talk about this. We'll go directly to the design tools. In the design tools, we can create a 2D line using coordinate or polyline feature. For example, if I want to make layer and I will have a line drawn here, and I want to create 2D line from this line. So simply what I will do, I will select polyline feature. It will directly select the draw line. I will give the track number, for example, 5. It will start by 1001, 50 bin increment descriptor. If I want to create parallel line, I can also create. I will click generate, and immediately I will get a new 2D line. Okay, with the distance we mentioned. And the thing I wanted to mention is sometimes if you go to the middle, you will see that the point is a little bit shifted from the line. This is just visualization issue because I am using the leaf map, layer, and leaf map layer only support the Lambert projection. But if you take these two layers on GIS and open it, it will open exactly one over each other. So don't worry about it. It's not a big issue. The coordinates are correct and it's calculated according to the selected projection. The other tool is generate 2D line is when I can use table, for example. Let's say sample project. So what I have here is the coordinate, the line number, and the start of end of each line, and what is the first bin for each line, what is the bin spacing for each line, and what is the bin increment for each line. I will come here directly and I will use this file. Let's take directly the line number, start, end, just make check. First bin, we have the first bin spacing, bin increment, offset from start, and perpendicular offset, we can keep it 0. I will generate this. So it will directly generate all the lines in the CSV from its start, from its end, and you can export it to any format you want, or you can export it to the database. The other method is to generate a 3D grid. The 3D grid is simple. You just need an origin point. So for example, I want to build a 3D project here with direction 0. So I will pick the coordinate. So this is our easting. This is our northing. Azimuth 0. I will first line will be 1001. Between line is 300 meters. Number of tracks is 20, let's say. Bin track increment is 6. This is the parameter of the normal simple 3D lines. First bin will be 4001. If I want to clip it to boundary, I will choose the boundary. If no boundary, we just select no, do not clip. And the clip tolerance is how many the distance from the edge we can keep the point. So if the point, for example, far on the boundary edge, 4 meter or 5 meter, we can put a tolerance so we don't remove it. So it's simple to generate a 3D grid line with the specific distance we mentioned, 300. 300 between and 50 meter between points. This is the design tool for 3D. Also, we have a very interesting tool is the 3D pattern. So I can make a 3D pattern using, for example, specific uh, origin point, also track at origin, bin at origin. But the grid parameter will be the track spacing, bin spacing, all these for the grid. How many bin in pattern? I will have 8 by 16. So this is all the parameter for the pattern. Anyone work with pattern in 3D, he understand what is this parameter. Also, I can use repeat, so I will repeat this 10 by 10 to repeat this pattern. So I will create a 10 um, 10 repetition for a long track. So I will repeat this pattern which is 8 by 16, 10 times by 10 times. Generate direction to the right. I will build the pattern now, so I can make it like this. This is very famous 3D grid pattern. So you see the pattern we built is just this, and it's repeated 10 times by 10 times, so you get a full grid of data. This is the 3D pattern. Also, we have another method is the vibrator pattern. After we build a 3D pattern, we can generate a vibrator pattern. So each point I can get 1 point before and 1 point after. So what I get, I will, if I have template, now I have template that has 15 meter before the point and 15 meter after the point. I will keep it, 9 field track, calculated azimuth, or I can use the manual azimuth, include or not include the original center point. So what we get before each point and after each point, we have the 2 points. Okay, so this is the direction. It took our direction, which is this direction, the line direction. Also, I added to the design on map the generate secondary layer that we mentioned before, just for sometimes we use it in offset, sometimes we use it in design also. So after we make a 2D line, we generate a secondary layer. So it's belong to the offset and belong to the design as well. I think by this we cover all the SQL query application. You have something I didn't mention. Maybe I can't. I will not make a new video for it. We have something here, the QC. The QC has different method. We can check the proximity between points, the line separation check, spread check, numbering check, and elevation anomaly check. So all this you have it in the QC, and you can apply it to any layer you visualize or any query you visualize on the map. You can apply the check the QC for it. By this, I think we have covered most of the important things in the seismic survey application. I will be happy to receive any feedback from you if you tried the application or you want to get a license for this application, for this software. I will happy to hear from you. Thank you so much and see you next time.